Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Lin. Thanks for meeting me during office hours to talk about my project on human-robot interaction design.
Good afternoon, Miguel. Tell me about the focus of your project and what design questions you want to address.
I want to create an intuitive interface for a collaborative robot that helps workers assemble electronics. I am not sure which modalities to prioritize and how to evaluate usability.
That is a classic HRI design problem. You need to think about intent communication, shared autonomy, and safety. Which of those are you leaning toward right now?
I was thinking of light signals and a simple gesture recognition system. Maybe a haptic nudge for the human to take over, but I worry it may not be clear enough.
Light signals and gestures are useful, but consider redundancy. Multimodal cues like lights, sound, and haptic feedback can reduce ambiguity. For assembly tasks, visual cues help when workers are focused on components. Haptics work when hands are busy.
So redundancy improves interpretability. How do I decide which modality to use at each moment?
Design a context-aware interface. Use task state and user attention models to adapt. For example, if the worker is looking at the part, use minimal lights. If the worker is occupied, use a haptic tug to request attention. The interface should also be transparent about autonomy level.
When you say transparency about autonomy level, do you mean showing what the robot plans to do next?
Exactly. If the robot intends to move into the shared workspace, the interface should communicate intention clearly. Humans need to know whether the robot is in autonomous mode or waiting for human input.
That makes sense. I read about proxemics in social robotics. Is that relevant in industrial cobots too?
Yes. Proxemics, or spatial behavior, is crucial. For collaborative tasks, you must define safety envelopes and comfortable zones. The robot should respect personal space but also move efficiently. You can implement soft boundaries that expand when the human is focused elsewhere and contract when the human looks toward the robot.
What about trust calibration? I want workers to trust the robot but not over-rely on it.
Trust calibration is a core design goal. Too much trust leads to complacency. Too little trust prevents collaboration. Use explainability cues. For example, the robot can present concise reasons for its actions. Short text on a display or a brief verbal confirmation can be effective.
Could you give a concrete example of explainability in a cobot?
Sure. Imagine a robot that will hand you a screw. Before the robot moves the arm, a small LED arrow points to the screw and the speaker says, "Handle ready." If the screw is misaligned, the robot can indicate error and request human correction. That short explanation helps the human understand the robot's state.
I like that. Should I prototype with Wizard of Oz testing or build a real control stack first?
Start with Wizard of Oz for early user studies. It lets you explore interaction patterns without full autonomy. Use formative evaluations to iterate on interfaces quickly. Later, implement the control stack and run field trials to measure robustness.
What metrics should I collect in those studies to evaluate the interface?
Collect objective and subjective metrics. Objective ones include task completion time, error rate, and number of intervention requests. Subjective metrics include perceived workload using NASA TLX, trust questionnaires, and perceived transparency. Also log communication latency and fail-safe activations.
How about learning and adaptation? Should the robot adapt to each worker's preference?
Adaptive interfaces can improve efficiency and comfort, implement gradual adaptation, and allow easy resets. Use co-adaptation, where both the robot and the human adjust. But guard against unexpected behaviors. Provide users with an undo or override option so adaptation remains predictable.
I am also considering gesture recognition for commands. Any pitfalls there?
Gesture recognition is powerful, but error-prone in cluttered environments. Keep the gesture vocabulary small and distinct. Combine gestures with contextual verification. For example, require a short confirmation gesture or a voice prompt if ambiguity rises.
Should I worry about cultural differences in gestures and proxemics when designing for a global workforce?
Yes, personal space preferences and gesture meanings vary. If your deployment is multicultural, prefer more universal cues like lights and simple spoken prompts in the local language. Also involve diverse users in participatory design sessions to surface hidden assumptions.
Do you know any case studies I could cite that combine these ideas?
Look at Baxter by Rethink Robotics for collaborative assembly examples. Also research on assistive robots in healthcare that use proxemics and multimodal cues. There are studies showing that adding a light band and verbal prompts reduced intervention time and improved trust scores.
Great. For my final demo, I want to show a scenario where the robot and worker switch roles smoothly. Any advice for the video script?
Script a sequence that highlights intent communication, a safety event, and a recovery. Show how the robot signals intention, how the human responds, and what happens when the robot requests human assistance. Emphasize measurable improvements, like fewer errors and lower workload.
That helps a lot. One last question. How important is aesthetics in interface design for cobots?
Aesthetics matter for acceptance. Clean, consistent cues improve learnability. Visual simplicity and predictable motion can also affect perceived safety. But do not sacrifice functionality. A clear, simple aesthetic that aligns with the interaction model is best.
Thank you, Professor Lin. I will start with Wizard of Oz tests, focus on multimodal redundant cues, and measure trust and task efficiency.
Good plan. Remember to document participant diversity and iterate based on both errors and user explanations. If users cannot understand robot intentions, trust collapses, and the collaboration fails. Send me your study protocol when you have it, and we will refine the tasks and metrics.
I will. Thanks again for the guidance. I feel more confident about the HRI design choices now.
You're welcome. Good luck with the prototype and schedule another meeting after your first user study.
Listen again to part of the conversation, then answer the question.
If users cannot understand robot intentions, trust collapses, and the collaboration fails.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.